going to happen on this Friday's quiz is going to be a modeling project. Okay? Not modeling as in this, but modeling as in you're going to try and figure out an equation to describe a situation. And then we're going to run your equation through and see how well it performs in that situation. And your grade will depend on how well you did, or how well your model did. What are you talking about? Well, if you go on YouTube, see if this will do anything for me. Okay, so, there we go. So let's go to youtube.com and get rid of the rest of this. It's insisting that we go to Canopy. So let's try YouTube. And you do a search on YouTube for something other than stupid cat tricks, like egg bungee project. Have you ever done this? I'm seeing one or two heads, but a lot of people are, what? I'm thinking, fantastic. Okay, so this egg bungee drop stuff, what's the deal with it? Watch a couple of these. Basically what's going to happen is, okay, some of these are more exciting to watch than others. This one's with a Barbie doll that's up at the top of the screen now. We're going to do eggs. But what the basic idea is, you all know the premise behind bungee jumping, right? Okay, you put some bungee cords around the ankles, you jump off a 400-foot bridge, you go, and you just barely miss the stream down at the bottom of the bridge. And you go up and down a few times. The thrill of bungee jumping is barely missing. Not missing by 150 feet. I mean, what's in that? Okay, barely missing. Okay, so what's this have to do with anything? Well, this coming Friday, your quiz is going to be, can you do a model? Can you do regression on data? I'm asking you to watch a few of these because it'll give you some examples, some idea of what's going on. You can see it. There are a lot of these. Okay. Ooh, the world's highest bungee jump. There you go. Okay. The one in the middle of the screen is people, not eggs. What we're going to wind up doing is we'll use eggs so that nobody gets hurt. Okay, and what the deal is, Friday, you're going to be given a raw egg. Be careful. You've only got one egg. If you break it, I don't know what you're going to do. Run over to Kroger's quick like and get back here in time to finish your project after having driven to Kroger's and back. Good luck on that. You're only going to be given one egg, so be careful. You just said that, Chuck. Yeah, I know. I wanted to emphasize it. Okay? Yeah?
Are we allowed to buy our own eggs?
No. And you can't bring in hard-boiled eggs and eggs that have a coating of epoxy or rubber eggs, or you can't soak it in vinegar ahead of time and leach the carbon out, or calcium out. Yeah.
So if I say, you want to drop this, I can't bring an extra egg just in case I drop it.
No, it's kind of like jumping off a bridge. We don't bring an extra myron in case we accidentally drop the first one. We only have one myron, and we got to take good care of him. Okay? Some people write names on their eggs and name them in the whole routine. But what the deal's going to be is you're going to be given 3 rubber bands, a paper clip, an egg, and this year, for the first time ever, we're going to go with Ziploc bags. I always use the netting. I may still use the netting. You know that the apples and things come in? You wrap the netting around the egg. And then with the paper clip, you can unfold the paper clip, right? And you kind of loop it through a bunch of the netting so that you can hold the egg in the netting without the egg falling out. The thing I like about netting is it makes for a more spectacular crunch. And then what you're going to do is you're going to have your paper clip, and you're going to have your netting, and your egg's going to sit in the netting. You're you're going to take one rubber band and loop it through. Okay. Everybody's going to have a meter stick. And what you're going to do is you're going to put your meter stick like this. Put a pin or something like that coming straight out. Put the rubber band over the pin. And then you're going to lift using the top of the paper clip. How you release is important. If you don't release right, this thing's going to bounce back and forth, and when it bounces back and forth, guess what it always bounces into? Right, the meter stick. And when it hits the meter stick, what's it do? It breaks. Okay, so while everybody else is finishing their project, you're washing floors. But what you want to do is from the top of the paper clip, hold this up so that the bottom of the egg is even with the pen. And you release it. And it's going to come down some amount. It'll stretch because of the rubber band, right? And it'll bounce up and down. Now you may want to catch it and not let it just bounce forever and a day, because they bounce into desks, they bounce in, you name it, they bounce into it. But what you want to do is figure out how far down did it come. And you're going to take some data where you have the number of rubber bands and the total drop distance. You're going to be given 1, 2, 3 rubber bands. So the first time you just use one of them. The second time you take one of the rubber bands and you loop it through the first one. So now you've got a deal like this. Okay? Does that make sense to everybody? You do the same thing. You pick it up by the top of the paper clip, hold it even with whatever you got out there for your diving board, and drop it and see how far down it comes the second time. People will often take a piece of paper and hold it, and so if the egg touches it, you can tell when she's barely touching it, and it's not going to break the egg to hit a piece of paper. So folks will often take and hold a piece of paper like that to get a measurement of how far down it dropped with 2 rubber bands. So you're going to have, and I'm making up something or other, let's say 23 centimeters, 36 centimeters, and then you're going to put a third rubber band on it and drop it again. And get a total drop distance with 3 of them, and I don't know, let's say 50 centimeters. That gives you 3 pieces of data, doesn't it? You're going to have to plot it, figure out what type of an equation best fits that data, come up with an equation for that set of data, linear, quadratic, whatever it might be. You're going to have to somehow or another come up with the equation, and then comes the fun part. Because I'm going to come around with little slips of paper. And the little slips of paper are going to say things like 6 feet 3 inches, 4 feet 10 inches. And everybody's drop height is going to be different. And even if they were the same, are the eggs the same? Do the eggs have the same mass? So the eggs are going to drop differently. So don't, oh yeah, the answer just came to me. Come over there. Their egg's going to behave differently than yours. Okay? So you got to figure it out based on yours. And what we're going to do is up here at the front of the room, we're going to have the heights marked up here. You come up with your meter stick, your tab that says what height you're dropping from. You line up the meter stick there, put your egg out, and guess what you got to figure out for your system? You've got to figure out how many rubber bands to include, don't you? I've already hooked up that many paper clips or rubber bands. Somebody's going to hold the meter stick. Be sure you get it level, because if you tip it down, what's going to happen? You're going to be too close to the ground, aren't you? And everybody knows what you're going to get, an omelet. Okay? Hold it up job's going to be hold it up level, slide the rubber bands on it. So you're going to want this meter stick on edge, because if you have it this way, it takes up a whole lot of the rubber band on the width of the meter stick. Have it on edge, hook it over, pick up the rubber band so that the bottom of the egg is wherever you've been holding it. Rub it. Your grade depends on how close to the floor you come. This is a bungee jump. The thrill is in barely missing. And the cool thing is now we can video this stuff in slow motion, can't we? And we can get a measurement of what your miss distance was. Well, hopefully it's going to be about this far off of the floor, and then it'll pop back up to here and you grab it. Okay? Your grade depends on how close to the floor you come. Now, if you crash and die, you get a 5 out of 10. Ooh, that's better than 0, I guess. Okay? But you don't get much of a grade if you crash and die. Okay? I think for a minor crack, just a little boop, you get about a 6 or a 7, or about a 6, something like that, out of 10. But, and I've got it all on a scale. It's written out on what your grade is based on how close you came to the floor. And it's kind of cool because, well, people have fun with this. It's kind of fun to watch the other groups jump. And the catch is, everybody's got a different height, don't they? I mean, 6'3" and 4'10" are different enough that you can't use the same number of rubber bands on them. And some people get real adventurous and we're going for the 10. We're going for the 10. Oh, we got an omelet. Okay? And other people are going, we're going to avoid the omelet. We're going to avoid the omelet. And they come and they miss the floor by this much. Well, that's not a very good grade either. Okay, that's about a 6 out of 10. So you got to push it. Yeah.
You only get like one drop.
You get one drop. Yep. And we're going to videotape them in slow motion. If some of you want to do the videotaping, trust me, you're probably better than me on videotaping, well, videoing with these things. Okay? And the grade will be dependent on how close to the floor you come.
Oh, you saying our goal is
As close to the floor without hitting it. As close to the floor without hitting it. Yeah. So you want to push it, but you don't want to push it too much. Okay? Now, what we're going to talk about today is, we're going to talk some more in chapter 2.4 about modeling. Modeling talks about coming up with equations to fit data. One of the places where they really model is in coming up with bungee cords of the correct length for various bridges and things for people to jump. True? Because when they make that bungee cord, the people who manufacture it send out a chart with it that says, if you are jumping from this height, this is how long of a bungee cord you can use. If you are jumping from this height, this is how long. And they got to know how that bungee cord performs over a variety of weights. And if you're running it, you've got to adjust the bungee cord length based on the weight of the person off of the bridge or whatever. Because you don't want to be killing people. Really bad advertising. Okay? So what we're going to talk about today is, how do you model a situation? We'll start out with some simple ones. We'll move into some data. Okay? Watch some of the videos between now and Friday on YouTube so they got an idea of how to do it. A lot of them use a Ziploc bag. I don't know, I might use those. I'm kind of old school. I really like the netting and the splash and all that stuff. It's more fun. You know, there's not much excitement to an egg breaking inside of a sealed plastic bag. Does that make sense? Are you okay? So that's going to be your quiz on Friday. It's going to take about the whole class. Okay? Because you're going to have to do 3 experimental drops, aren't you? So you've got to collect data. Then from collecting the data, you've got to graph it and come up with an equation. And then from the equation, you've got to compute how many rubber bands do we use and get the system set up. And then we got to have time to jump. So does that make sense? Where we're,
Yeah, I got one question. So what's the question to the equation?
okay, we'll work through one today, something sort of like it. Tell you what, let's do. Let's work with this right now. There's some data. I'll erase these little jump stickers, the jump heights. Let's say that you've already assembled it. You've done a jump with one rubber band, a jump with 2 rubber bands, and a jump with 3. And those are the various lengths that you've gotten for jump distance. Now what you want to do then is to get an equation to describe your egg in your harness for various jump heights. First thing you've got to do on that data is decide what's x and what's y. X is the rubber bands, because you get to pick how many rubber bands you put on it, right? Now remember, they're not next to each other, they're in a long line, aren't they? Okay? So what's going to happen is X is going to be the rubber bands. The total drop distance is going to be what? The Y value. Does that make sense? So let's go ahead and graph this. So we have 1, 2, 3. And remember, those are rubber bands. So let's go 10, 20, 30, 40, 50. And this is how many centimeters, not inches, but how many centimeters the egg fell based on that 1 meter stick. Does that make sense? So you may have to drop it several times at a specific height to get it to the point where the egg just barely touches the paper. Okay, so when you're getting your data, you may have to experiment some, because if it goes, you don't exactly know how far down that egg went, do you? Move the paper down some more, maybe it goes like that. It can go down a little further, and it goes bing and just barely ticks it, and you look at that height. Make sense? Okay, so let's plot this data. 1's going to be 23. 2 is 36. And 3 is 50. What's that data looking like? Parabola? Nope, it's looking like kind of like a line, isn't it? Okay. Now, with a credit card or whatever, you can experiment lining it up differently, because odds are the line's not going to exactly hit all 3 dots. This is data. It's not perfect. You've got to find a line that best goes through those points. It may go a little higher than some, a little lower than some. You want it so that it is closest to the middle, if you would, of your set points. Here's a little bit of guessing in here, isn't there? To improve your accuracy, what you may want to do is bring in a full page sheet graph paper. Because the bigger you make your graph, the less error there is. Does that make sense? The more accurately you can place it. For example, here, I just kind of guessed where 23 was, didn't I? If it was a bigger piece of graph paper, would it be clearer where 23 is? Yeah. Okay, so if you bring in like an 8.5 by 11 sheet of graph paper, or I'll see if I can get some run off, it provides for greater accuracy. Now, how are you going to get the slope there? That's right, we're going to choose 2 of the points. And you may want to kind of experiment. If I pick points 1 and 2, for example, so if I do 1 and 2, that's going to give me the points 1, 23 and 2, 36. So the slope is going to be the 36 over the 2 minus the 23 over the 1, which looks like about 13. Does that make sense? Then I'll try points 2 and 3. Well, that's going to give us 2 and 36. Point 3 is going to be 3 and 50. And that's going to give us a slope then of 50 over 3, 36 over 2. That's going to give us a slope of 14, isn't it? And if I try points 1 and 3, just experimenting, we're using 123 and 350. That's going to give us a slope of 50 over 3, 23 over 1. So that's going to give us about 27 over 2, which gives a slope of 13.5. What would you estimate is a good choice of slope value for this particular? It's kind of in the middle, isn't it? I'm sorry, I interrupted you. I apologize. Is that okay? Okay, I mean what I said, it's kind of in the middle. Okay. So a slope of about 13 and a half. Does that make sense? What do we need to get now if we're going with the linear model? Let's see, if it's linear, it's going to be y equals mx plus b. We need to get the b value, don't we? We know what m is. Well, we can experiment around. If we use point 1, the first point, which is this 123, y is going to be 23 equals 13.5 times x is 1 plus b. If you solve for b here, what's that give you? About, let's see, 19.5. Does that make sense to everybody? Well, that's not quite right. How about 9.5? Yeah, that looks better. Okay, now, are we going to go with just that as an estimate of b? Well, we could also do it with point 2, which is going to be 236, which is going to give us 36 equals this 13.5 times 2 plus b. So it's going to be 27. And let's see, 36 minus 27 is what? Get about 9 for b. And we could play with the third point as well, couldn't we? So what's it look like the b value is going to be around? 9, 9.5. So what's in between there? Maybe 9.25. Okay. So what I could come up with here is I can say, okay, it looks like my b value is about 9.25. The slope is about 13.5, which gives me an equation y equals 13.5x plus 9.25. Is everybody good? Okay. Now keep in mind, y is the drop length, isn't it? X is the number of rubber bands. Does that make sense? Everybody's okay? Suppose you draw a drop height. Well, I made these up in centimeters up here, so we'll keep it in centimeters. Friday will probably stay in inches. Okay. Yeah, we'll do inches on Friday. Everything works exactly the same. The numbers are just a little different. Okay. But let's say this is about a 130 centimeter drop. You want to be able to drop it from 130 centimeters. So 130 centimeters is not too far. It's about 10 inches above the chalk tray, maybe. So you want to be able to put your yardstick there, put your little egg out there, drop it, and just barely miss the floor, like by that much. Okay. Oh, the group that gets closest will get an extra 10% bonus for a scary jump. Okay? Makes it worth messing around, doesn't it? Okay, yeah. Whoa, wait a minute. Back it up, Chuck. You said the group? Yeah, you'll be allowed to work in a group of 3 or 4 folks. Because it's hard for you to hold the meter stick and drop the egg and down here see how far it comes all by yourself. So collecting data and stuff is going to take several people. Okay, you as a group draw a drop height of 130 centimeters. And the question is, how many rubber bands do you want to set this up with? Are you allowed to do experimental practice jumps? If you go down to Brazil and you jump off that bridge, the first time counts, doesn't it? Okay? Same deal with this. First time counts. Well, how are we going to figure out how many rubber bands you need? Well, let's move back up a little bit. What variable represents the number of rubber bands? X does. What does Y represent? The drop height, doesn't it? Okay, so I need to remember that. Y is the drop height. So that gives me this equation, 130 equals 13.5x plus 9.25. That's going to give me this 13.5x equals, subtract 10 from that, it's going to be 120.75. And now, take this 120.75, divide it by 13.5, oh, this is interesting. X equals 8.94444. Now, here's where the gaming comes in. If you use 8 rubber bands, is that going to be a very good jump? Logan's saying, I'm not very excited about an 8 rubber band jump. Why not? Well, I don't know, would it? This is saying to jump 130 centimeters, how many rubber bands should you use? Almost 9. So almost 9 will get you to the floor. So what's 8 going to do? You're not going to hit the floor, are you? That's okay. We're experimenting, okay? It's okay. What's 8 rubber bands going to do? Going to miss it, isn't it? By very much? Probably. What's 9 going to do? You're probably going to hit the floor, aren't you? So how are you going to deal with that? You're not allowed to cut the rubber bands. I'm borrowing from the secretary, and I don't want to show up with cut rubber bands. However, can you tie them so that they're only a portion of the length of a full rubber band? Yeah, as long as you untie them. I got to take them back, normal rubber bands in a box. This is where it gets fun, and it's interesting to watch groups, especially where you have some people who are more, I don't think I want to do that, shall we say, squeamish, and some people who are more risk takers in the same group. No, don't use that much rubber. Yeah, let's use a little bit more of that. And as a group, you got to come up with a final rubber band length.
I wish there was some way to do the equation before we do this, so we can know like how many rubber bands. Like.
Yeah, that would be nice to be able to do it ahead of time, wouldn't it?
Yeah.
But there are things in life you don't get redos on. In fact, most of life you don't get a redo on, do you? You get to make that statement once, and then you live with it for the rest of your life, whatever it was. So, gentlemen, pick your statements wisely when you get married. It's a long marriage on some of the statements. Does this make sense where you're going Friday? It's fun. Folks have a good time with this. Okay? Please? This is a cool problem. Yeah. You can form up teams however you wish for Friday, 3 or 4 in a crew. You really do need at least 3 people. Okay, a group of 2 is not going to work well because you got to have somebody holding the meter stick and the pin up here and somebody dropping it and somebody reading how far it's going. Bringing a ball glove or something. Does this make sense where we're going with this? So let's talk a little bit more about how do you model things. Does it make sense what we just did there? How many of you have a TI-83 or an 84? Whole bunch of you? Let me show you real quick, like here, how to do this on the TI-83 or the TI-84. And I'll make it into a movie, or in this movie. There we go. There we go. How about that? Is that cool or what? Okay. Let's see here. Yeah, it's going to bury it. Okay. So slide this over like this, trying to block out some of the background. If you got your TI-83 or 84, fire that puppy up. If you don't have one, you may want to slide over next to somebody who does. Friday, when you form your teams or your groups, you're definitely going to want somebody with a TI-83 or 84 because these things are kind of handy for the creation of the equation. Okay, first thing you want to do, go to y equals. Okay, so on your calculator, you press y equals. Do you have stuff in there for y1, y2, y3, whatever it might be? Press clear and get each of the y equals to cleaned up. Okay. Next thing you're going to do. So we've cleaned the y equals. And if some of you are having troubles reading, you want to slide a little closer to the front for this, that's fine. If you're having trouble seeing it. I'll post the movie and hopefully I'll make it easier to see too. Okay, next thing you're going to do. Second row, third button says, what's that button say? Stat. It's short for statistics. Press statistics. And on statistics, the little toolbar says edit, calculate, and tests. What we want to do right now is edit. We want to set up a little Excel spreadsheet. So we're going to do option number 1, which is edit. So I come down, press the number 1. Now, you may have numbers on list 1. If you do, the way you clear them is with the arrow key. You move up until list 1 is highlighted. When it's highlighted, press clear. Do not press delete. Delete will eliminate that whole list. But you press clear and then enter. List 1's clean. List 1 is going to be your x values. List 2 will be your y values. So for list 1, I'm going to enter 1, press enter, 2, press enter, 3, press enter. Then with the arrow key, I'm going to move over to the second column. And if you take a look at the data, one rubber band went 23 centimeters in this case, so we'll put in 23, press enter. 2 rubber bands went 36, press enter. And 3 rubber bands went 50, press enter. Everybody good? Next thing you need to do is you need to figure out what shape is this data. Is it really linear or is it quadratic or what is it? So you need to graph it. Well, to graph it, we need to set the window. In this top row of buttons, the second one says window. My x minimum, I don't need to go in the x direction from -10 to 10. My x values only go up to 3, don't they? But I'd like to have a little space around it, so what I'll do is I'll press -5 for my minimum, press enter. For my maximum, I'll probably press something like 5 is the maximum number we go to. The scale talks about how often do you want a tick mark. Since we're just going from -5 to +5, 1 is fine. In the y direction, for the minimum, if I start at 20, it's going to leave off a whole bottom part of the graph, isn't it? Because it'll start the graph at 20. I'll start at something like, let's say we start at negative 10. X scale, I got deleted somehow. 1. I'm going to try my x minimum as a negative 10, my x maximum as maybe 60. So there's a little space. I'm sorry, my y minimum is negative 10, my y maximum is 60, and my y scale is, let's try something like 10. What that does is it makes the window that the data is going to go in. Does that make sense? This next maneuver is very important. Press the blue button and then come up to y equals. Above it in blue it says stat plot. What this is going to do is it is going to set the calculator to plot the data. We're going to go with plot number 1. Mine, notice it says it's turned off. I'm going to press enter. The first thing I want to do is turn the plotting mechanism on. So I'll make sure the cursor is on the on. Press enter. And now it's going to plot. How do we want to plot? Well, we can do box and whisker plots and bar graphs and all kinds of stuff. We don't want that. We want a scatter plot, which is the first option. So that's fine. The X list is in list 1. Is everybody okay with their X list is list 1? Is that on your calculator? Okay. The Y list is list 2. And then how do you want to plot the points? You can use boxes, crosses, or dots. Personally, I'm not quite sure why it's going down. I'm not going down. Huh. Interesting. Oh, well, I guess we're going to leave it like that. Okay, for whatever reason, that's not working. Now, what we've done so far is we have deleted any equations for y equals. We've put the data into a spreadsheet. We've got this set up to plot, and over to the far right side it says graph. Let's see if that'll do anything for us. There we go. Do you see it's got the 3 points plotted? What's that look like? That looks pretty linear, doesn't it? So the next thing we're going to do, that doesn't mean Friday's data will be linear. It just meant the numbers I made up were linear. Okay? So don't just assume, oh, Chuck said it's linear. No, go with what your data says. Next, we're going to go to stat. Press enter. Now, we don't want to edit the data. We've got our data in. It's fine. What we want to do is we want to come over to calculate. Crud. There we go. Okay. So we come over to calculate. There's a variety of different types of equations it can calculate. It can do, number 4 says lin reg. Reg means regression. That just means make an equation from the data. 5 is quad reg, so that's a quadratic. That's stuff that looks like a parabola. Cubics go up, come down, and back up. And you can keep going on down the list. Wow, there's all kinds of stuff. Look at all this stuff here. Man, all kinds of options. We're not going to get into some of these messier ones. I'm just going to stick with, in my case, it looked like it was a linear regression. So I'm just going to stick with linear regression. I'll press enter. Okay, does everybody's calculator display like this after you go to linear regression? Is anybody showing anything that looks different from this? Okay, good. Because mine's older than this, so it doesn't run so great. Okay. You want to make sure that the X is list 1. Yep, that's where it is. The Y is list 2. Yep, that's where it is. Frequency lists, we're not worried about that. That's not going to be part of this problem. The next thing, store regression. That means it can actually retain or store the regression equation just like what it says. In this case, let's not worry about that. Come down to calculate. When calculate is highlighted, you press enter. And, wow, look at that. Are the numbers that the calculator is giving back pretty close to what we got? It has a slope of 13.5 and a b-value of 9.333. I forget what the b-value was. I think our slope's just about dead on. What this allows you to do then, if you work it through this way, is you can come up with your equation, okay, and you'll be able to write down y equals 13.5x plus 9.33333. Does that make sense? And this is the equation then that you will use. Now, everything's going to be inches on Friday. Can you convert 5 foot 8 inches to just inches? 5 feet's how many inches? Okay, 1 foot is 12, and if you have 5 of them, that's 12 times 5, so that gives you 60 plus the other 8 inches, so it's 68 inches. Okay, if you've got 6 foot, that's how many inches? 72. Yeah. Okay, that's okay. You can. It sounds like you're okay with that. So there are a couple ways to work out the equation. Now, one of the things that will also show on these. Well, this one doesn't. I'm not going to chase it down. It may have an R displayed here. And if R is 0.9 or something like that, that means the equation fits the data really well. Another way to check to see how well it fits is to go to y equals, and we can put in as 13.5x plus, and we had the 9.444. There we go. Let's see if that's, yeah. So if we graph this now, it'll give us the data. And do you see it'll show you the line going up through the data? Check and make sure that the line fits the data before you jump the egg. Because if the data is going up like this, and your line is going like this, are you really going to trust that? Okay, so make sure it makes sense. Does that make sense to everybody what we're going to be doing here on Friday? You may want to practice some of these. Don't just show up on Friday and say, oh yeah, I saw him do it once on the calculator. You may also, if you don't have one of the calculators, where can you get one of these for a while? The library. Pop into the library at the reference desk. Hi, I need one of the TI-84s. They'll ask for what? Your license, your driver's license, I believe it is, or your student ID. Okay, they'll take your student ID, even worse, because that's like a credit card, isn't it? That's right. Yeah, they'll hit you up for 110 bucks. Please? Oh, well, if you don't bring it back, period, they're going to ring it up at $110 and say, thank you very much, come again. Okay, or maybe 120, who knows what they'll charge you for it. Okay, does this make sense how to use the calculator? Are you okay? Yes, sir.
How did you put that line through it?
The way I put the line through it was I did y equals, and I put in the equation. I typed in 13.5x. Now be careful, the x is in the second row, second column. That's the variable x. Then plus 9.444. Once I got that in, then I came over to the top on the right-hand side where it says graph. Press that, puts the data up, puts the line up. Make sure it fits nicely. Folks have a lot of fun with this. And these things usually work out pretty accurate. What if two people come in tied? Because the extra 10% goes to the best jumping team, right? What if two teams tie? We'll do a jump off. Okay, a second round. Okay, till somebody fries or wins, one or the other. Either become an omelet or you get the idea. Does that make sense? Okay, we got a couple minutes here. Let's go after another example quick like. Let's say you got a tank. A tank, yeah. A tank, not as in the kind that you drive, but a tank is in, it's got water in it. Or a wading pool, something or other. Okay? It has 100 gallons. I've got a 100-gallon stock tank out for the cattle. They drink it dry once or twice a day. So the cows drink about 150 to 200 gallons of water a day. Yeah, it's amazing. Okay? They'll drink that water. Okay? So, anyway, now let's move this on down this way a bit. We've got this 100-gallon stock tank here. And it really does have a plug right about there where you can drain it. And if you don't have that sealed off with something like Teflon tape or something like that, it can leak. With a little rubber seal on it. Okay, these things can leak. Let's say it leaks a half gallon per minute. Okay, so I've just filled it up. It's got a pretty good leak in it. It's leaking half a gallon a minute. How many minutes until it is half full? How long will that go till it's half full? In other words, 50 gallons are left in it. 25 minutes? We're just guessing. We're just trying on clothes again, right? And if they don't fit, we're hanging them on the rack. It's not like anybody's bad and awful if the shirt doesn't fit right. Okay? We're not worried about that. We're just trying to get a start point. Okay, so let's experiment with 25 minutes. Well, first off, what does half full mean? It's halfway to full, right? Come on, Chuck. Half full means halfway to full. How many gallons? Let me rephrase it like that. 50 gallons. Okay, so half full. Yeah, way to go. It's 50 gallons. So we want to know how long is it going to take before it has 50 gallons in it. Well, let's experiment. 25 minutes was something that somebody tossed out. How much is coming out every minute? Half a gallon. So in 25 minutes, how much will that have allowed to come out? Well, let's see. It's the half of a gallon per minute times 25 minutes. And this could be made into a fraction. Just put it over 1. And notice the minutes will cancel. And the good news is we're going to be left with gallons, aren't we? What's half of 25? 12.5, isn't it? Okay, so that gives us a starting point. Is 25 minutes more than enough time or not enough time for this thing to go half empty? It's not enough time. It will have lost 12.5 gallons, and we're looking for it to lose 50. Does that make sense? Chuck, you're just kind of guessing. This isn't math. Yeah, it is. We know some information now. Our answer needs to be bigger than 25, doesn't it? Could we come up, we could keep guessing, couldn't we? And refining our guesses and guessing and refining them. But an equation's a quicker way to get it done, isn't it? Okay, so if we're looking for the volume at some point in time, the amount of water that's in the tank, well, how much does it start with at the very beginning, at time 0? 100. And as it leaks out, are we adding to or subtracting from the volume? We're subtracting from. Minus how much? It's 1/2 each minute, isn't it? Do we know how many minutes? Or is that what t minus 1/2 t? Everybody good with that? And the question is, what is t? Your question might be, what's that in front of t? It's supposed to be a 1/2. Okay? And what volume are we looking for? 50. So we want to know at what time do we get a value of 50? Equals 100 minus 1/2 t. Can you solve that for t? That's pretty straightforward, isn't it? How much time is it going to take before 50 gallons have leaked out? Thought I heard somebody say it. Yes?
Is it an hour and 40 minutes?
Yeah, 1 hour and 40 minutes. Way to go. Some of you thought it was 100 minutes, right? Minutes, an hour and 40. Which of those answers? 100 minutes, 1 hour, 40 minutes. What's the scoop of those two answers? Which is right? They're the same thing, aren't they? So if you're sitting there thinking, rats, I thought it was 100 minutes. That's fine too. Okay, is there anybody who was not able to solve that? Does that make sense? What, please?
How do you think it was 100 minutes again? But just by looking at the equation, or?
Well, from here, you could subtract 100, so you get a negative 50 equals a negative 1/2 t. Multiply both sides by a negative 2. And you get t equals 100. Okay. Wednesday, we'll take a look at some other models, like greatest integer and all kinds of good stuff like that. And take a look at some of those videos on that egg drop project. Watch some of them. There's a variety of them on there. Kind of get an idea for what's going on. If you have any questions, ask. I'll see you Wednesday.